Hi, welcome to another edition of Fun with Physics, the Newton's Third Law edition. These are your guided reading notes, and I'm going to go through them with you. If we don't finish them in class, you can watch the video at home to finish them. First, these two statements. A force is an interaction between two objects, like when your hand hits a desk. Both your hand hits a desk and the desk hits your hand at the same time. It's an interaction. And if you hit a nail with a hammer, the hammer hits the nail, but the nail hits the hammer. They have equal and opposite forces. So, you can pause the video at home if you need to, but I'm going to move on. Newton's third law says for every action there's an equal and opposite reaction. I don't know how I can put it other than when your hand hits a desk, the force on the desk from your hand when you hit the desk is the same as the force the desk hits your hand back. The key things is there's an action force and a reaction force, and they're equal but opposite. The opposite's their direction. So the hammer hits this way, the nail hits back with equal and opposite forces. The opposite being the direction. Equal meaning they're the same magnitude of newtons. Remember, the units of force are newtons. Forces always come in pairs. You can't have one without the other. I can't hit this desk without it hitting me back. I can't hit a baseball with a bat without the bat hitting the baseball back. Every time two things hit, both objects feel a force. They hit each other. They form in pairs. If you've ever played a contact sport like football, when you tackle somebody, you hit them, but you feel them hit you at the same time. Without an action force, there cannot be a reaction. If I don't hit you, you don't hit me back. It's real simple. Now, I drew a figure over here of a man pushing a box. This is a force on B from A. This is the force on A from B. B being the box, A being the man or woman, the person. So the force I put on the box is the force on the box from me. The comma means from. That's a comma. So the force on B from A, sorry about that, I made it a little clearer over here, and the force on A from B. That's how you say that. The action force is my force on the box. The reaction is the force from the box back on me. So I'm assuming you've written that down. Give you another second. So, weight and gravity. A boulder pulls up in the earth. With the same force as the earth pulls down on the boulder with. Weight is the force of gravity. Weight is the force of gravity. It turns out that when you have a rock and you let go of it, you get pulled down with a force of gravity, and let's say this is the earth is pulled back with a force of gravity. Now, does the boulder fall, a rock fall? Yes. Why? It's much, much smaller in mass. What's going to be easier to pull, a big mass or a small mass? The Earth actually gets pulled up, but it's so big it doesn't hardly move at all. A rock is much smaller compared to the Earth. Therefore, the rock falls down and the Earth doesn't move. Now, there's a cannon and it shoots a cannonball. It's in the book. She got this cannon. Inside the cannon is a small cannonball. The first thing you must realize, and I'll put some spokes on the wheel of the cannon. When the cannonball shoots, the cannonball goes forwards and the cannon goes backwards. The force on both will be equal but opposite. And we'll call A B and B A. This is B and the cannon is A. I'll let you draw that. The force is equal opposite, but here's the deal. I don't know if you know this, but a cannon has a very large mass. A cannonball has a much smaller, we'll put the ball here, much smaller mass than the cannon. If the forces are equal and opposite, and if you go back to F equals ma, if this is ma and that's ma, if you have a big force, a big mass, you're going to have a small acceleration. If you have a small mass, you're going to have a huge acceleration. That's why the cannonball fires off and goes really fast. The cannon rocks back, but very little. It hardly moves at all. Just remember, a big mass has a small acceleration, a small mass has a big acceleration. How does a helicopter get its lifting force? It gets a reaction force from air. The blades push down on air. The air pushes back. Equal but opposite forces. Okay,